Here we are again, CCNA3, version 7. We're moving on to access control lists. Well, we've moved on, but now we're actually going to do some. So recall that the access control lists are kind of there to filter traffic. They're not actually a firewall. And we use them for other things other than just filtering traffic. Sometimes we needed to identify traffic that needs to go a certain direction. Some might call that policy-based routing. It's a good example. So great. This is week 8. I was going to give you guys an extra lab. Probably won't do that because of the elections and everything that's going on. There are lots of good labs in here. And recall that to get to everything, you click here on the course content. Okay. With that said, let's take a look at lab 518. What we're doing here is we're going to put in an access control list here on router 2 to keep traffic from this 11 network from getting into the web server. And we're going to put a access control list here on router 3 to keep these guys over here from being able to get to these computers over here. All right, so we're using standard access lists, and standard access lists only identify the traffic source. So because of that, in order to make them as efficient as possible, we need to put them as close to the destination as possible. Because in that way, by putting the access control list as close as possible to the destination, we're identifying what the destination is. The destination is whatever you've placed the list close to. So that's the limitation with standard access lists. We still use these, especially for remote access, like on an SSH connection or a telnet connection to a router to remotely configure it. Those use standard access control lists. So everything's pre-configured, and we can verify that using our handy dandy send a PDU. So if we go and we ping from here to here, the first one might fail, but that's just simulating ARP, getting everything all set. So we can get from PC1 to PC3. And if we go from the 192.168.11.0 network to the .20 network, let's just do that. So if ARP has a chance to get working, and there we go. Our second ping is successful. So we've got the ability for traffic to go from the 11 network to the 20 network right now, and from the 10 to the 30 network. And what we want to do, or what our aim is to keep traffic from going from the 10 network to the 30 network, and from the 11 network to the 20 network. Step 2 here tells you what the intentions are. And when we have an access control list, we have to choose a direction that it goes in and an interface to place it on. So if we're starting with this one where we're trying to keep traffic from the 11 network from going to the 20 network, if the source is the 11 network and the destination is the 20 network, we're going to put the standard access control list as close as possible to the 20 network, and that's going to be right here on router 2. So it's a gigabit Ethernet 001. And we open up router 2. We can see here that there's no password. And lucky us, they tell us exactly what to type in for router 2. So first we type in the access list, and the access list is both of these commands, the full access list. But we start out by saying that this source needs to be denied. So, sorry, 11, the 11 network, this source right here needs to be denied. And right now we haven't figured out where we want to put it. We just know that that's the traffic that we want to keep off of our network. We're going to name the access list 1, or number the access list 1. And it's going to be 192.168.11.0. And we use a wildcard mask. The /24 wildcard mask looks like that. So recall, in practical use, a wildcard mask is an inverse of a subnet mask. So wherever there is a 0, we're saying pay attention to that, and wherever there's a 1, in this case we have 8 ones, we're saying ignore that. So just look at the network. So if we put that on there, at the end of every access list is an implicit deny. So if we had an access list that just denied traffic from here, and then the last implicit statement was deny all traffic, it's effectively going to stop traffic from working at all. Might be a good exercise to edit the access list when we're done to see how that works. But we don't want to do that. So we're going to add a permit statement, and we're going to let any traffic in, or effectively all traffic. So if you're not from this network, you can get in. So we're going to take a look at this particular access list. And it looks like exactly what we want. And you'll notice that the syntax is different here. And let's look at the running configuration, see if it does that show run. Let's see if it changes the way that no, okay. It puts the running it puts the statements in there just like you typed them in. Okay. Because it is possible to configure access lists, not exactly with this syntax, but in a similar method, where you get into kind of an access list configuration mode and then put in the statements. Okay. So we have an access list, but it's not doing anything yet. So if we go down here and we ping, of course, this isn't going to show from there to there. It was successful, but we'll do it again. So the access list is on there, but it's not doing anything. We need to apply the access list to an interface in a particular direction. So We get into configuration mode. And in this case, we have to get into interface configuration mode. And so there's interface 0, 0. See if we believe it. Oops. Oh, I see. That is gigabit Ethernet 0, 0, and then this is 0, 1 on the switch. So it won't let you move it out. So it looks like 0, 0, 1, but it's really 0, 0. So interface gigabit Ethernet 0, 0. Once we get into interface configuration mode, we can apply the access list. And we call it an access group. It's just different syntax on the interface than when you're actually configuring the access list. And the direction is going to be out. So the traffic's coming from here, going through the router. So we got from here through the router. And if you look at the direction that it's coming for this interface, from the perspective of the router, it's going out of the router. All right, and that's it. You notice that we're already half done. So if we exit from there, we do a copy, run, start. Oh, because we're not, I need to type int. So it's a good habit to get into. Save your configuration when you're done. Packet tracer isn't going to ding you on that, but you should probably just go through the motions anyways. Get in the habit. But now, if we wanted to go from here to here, we're gonna be out of luck. So you see there it failed. If we do it again, it failed. And it'll fail every time now. All right, so we did router 2. Now it wants us to do router 3. So we'll get on router 3. And it tells us, what does it tell us? It's nicer to be able to see the router while you're doing it. There it is, router 3. All right, let's enable. We know we're going to be configuring. Well, here, let's do this. Show access lists. Right now, there's no access lists. All right. We'll fix that. So what we're on to do here is keep people on the 10 network from getting to this network. So people here can't go over here. So we'll do IP. Oops. We'll do access lists. 1 deny 102.168.10.0. Put in the wildcard mask. Oh, that was that good as a dot, not a comma. 255. And again, if we left it on there like that, it would deny all traffic from everywhere. So we need to do any. So you notice we use the same access list number on the different routers. The access list number only is significant locally, so we can do that. And we're going to exit. We're going to do copy, run, start. We take a look, see how we're doing. We're not quite there yet because we still have to apply it. So if we go over here, and even though the access list is there, ping from there to there, and it's successful. So we haven't fully configured the access list until we've actually applied it to something. So we get back on, and we do interface gigabit Ethernet 0/0, and we do IP access group 1 out. And if we look how this is working now, there to there, no longer works. So we're blocking traffic from there to there, but traffic still goes through there, and traffic still go to there. So we're looking pretty good. And we know that we needed to do that in the out direction because traffic's coming from here, going through this router, and then coming out there. And from this router's perspective, on this interface, the traffic's outbound towards PC3. So if we ping from PC3 to PC1, it fails. So even though we're only blocking traffic the outbound direction on router 3, the ping goes over here to PC1. Then it comes back and gets blocked. So for that reason, we prefer to use extended access lists where we can put them closer to the source so that we're not taking up bandwidth on packets that we're going to end up dropping anyways. And you'll notice that our completion here is 100%. We go here and check results. All green marks. Great. And those are access lists of the standard variety. And again, we're placing the standard access lists as close as possible to the destination of the traffic because we don't specify the destination. So the destination is or should be where you place them. Well, next up are extended access lists, which add another layer of efficiency. And we'll get to those post-haste.